Hello, everybody, and welcome to the new series of tutorials about occupancy simulation models. In this new series, we are going to specifically talk about mandatory simulation model. And we have another type of simulation which is called optional simulation model that we will be talking about that in a later series. But in this tutorial, we are focused on being the scenario being mandatory. And as you can see on the background, I have the simulation running. I decided that I want to have a very simple demonstration in order to provide a good big picture for you to understand the main concepts and the benefits of this type of simulation. And later we will be discussing all of the details in greater length in different tutorials. You can see that we have an agent who is walking and performing tasks in the environment. There are a series of tasks and the activity areas are highlighted in here. So for instance, you can see that this agent is at the desk, and we have activated this area in here. The agent is walking around, and then he has a view which has been captured to a target area, and then although he is in the visibility area, potential visibility area, the view will be captured only if the agent is oriented in a way that the uh, cone of vision is actually aligned with the target. Otherwise, the visibility will not be considered and captured. And with that out of the way, I'm going to discuss some of the basic concepts in this type of simulation with you, and then we will come back to this BIM model to show you how it works. Okay, so what is a mandatory occupancy simulation model? Um, Mandatory occupancy scenario is actually very simple in a sense that it's a job description, but in reality is a series of tasks that need to be done. And the person who needs to do all of these tasks, we call him agent, or we call her agent. An agent is a person, a virtual person. I mean, in computer science, we don't necessarily assume that an agent is a person, but in our case, it is. So we would be actually in this type of simulation in this series, we will be combining two different types of simulations with each other. One of them is called discrete event simulation, which is the scenario itself. Discrete event simulation cares about the dependencies between tasks and activities, their orders, and when they need to be done. Some more things that we would not be considering in this simulation, like resource management and stuff like that. So discrete event simulation is done in large time slices. We don't really care what happens in between. But with agent-based model, we really care about the details. So the time slices are much smaller, and they are small enough to be accurate physically, and for that reason we call them time steps sometimes. And so the agent based model, when combined with discrete event simulation, gives us a pretty accurate picture of the activities engaged and accomplished, and the location and orientation and physical descriptions of the agent itself. And the scenario is unique to the agent, by the way, which needs to be considered. Okay, I want you to actually not be so afraid if you're not familiar with these concepts, because I'm going to simplify them and I'm going to walk you through all of them. So our agent is not actually something very secretive like James Bond 007, who does really bad things, or a clumsy detective who, despite being clumsy, accomplishes all of his tasks. Our agent is actually Peter. Peter is a normal person like you and me who has great dedication to his job and who wants to finish the tasks, and who is a very responsible person, by the way, too. Okay, so if we are working with Peter, it makes it more comfortable for me to explain it, and it makes it more comfortable for you, hopefully, to understand it. Let's take a look at the sequence in Peter's scenario. Okay, let's say that we are working with the law office. Peter receives a call from lawyer one. It could be a call on the phone or a pager or something like that. And after that, Peter goes to room one where lawyer one is there, and then Peter takes orders from lawyer one and then goes back to his desk and completes the assigned job by lawyer one at his desk. Okay, so this is what's happening in a sequence. But I want to abstract that for the sake of presentation. And for the abstraction, I'm still happy to call this sequence in Peter's scenario a sequence because the name is very self-explanatory. A sequence has a name, let's like such as lawyer one call, and it has navigation in it from Peter's location to the location which the lawyer one is, and it has engagement with activity, it has navigation again, and it has another engagement with activity. So this abstraction is actually going to be very helpful for us. Let's just start with navigation. Navigation is walking from one point to another point, and often this navigation is between one point, an activity area, to another activity area, but it can be from any point to an activity area. An activity has a location in which the activity is engaged, it has a duration of time, and it has a direction. The direction is so let's say that you are next to the lawyer. Peter is next to the lawyer. Peter will not be turning his back to the lawyer when he's uh, engaged in a mutual activity with the lawyer. He's like oriented correctly. And a sequence has a list of activities in it, and it has a duration for repetition too. So we have duration for activity and sequence, and they have their own distributions. We will be talking about them later, but duration is important. So, for instance, if Peter is done with this activity, then this sequence may repeat itself after, let's say, 15 minutes. So we have the office description has two lawyers who have their own rooms and a waiting area for two clients. Peter has his own desk. And what about the building layout? Do we really need the building layout? Yeah, you would be surprised to know that most of the simulations that are out there in the market, they really don't care about the simulation, the building layout. It's because they are purely using discrete event simulation, or the level of uh, importance for a building layout is actually pretty low. But here we have the possibility of considering both of them in great details in OSM. Okay, with that said, let's go back to our BIM model. I'm going to stop this simulation here, and the correct way of doing that is to stop the simulation and to clear the agent, and then you can go ahead and close everything. I'm going to start something from scratch, and as you have seen, I have changed the scheme of the windows. It's because the older scheme of Windows 7 was competing with other resources that my computer has, and it made the simulation look very slow, which I didn't like. So I actually reversed the scheme back to one of the old Windows schemes to make more resources available for Camtasia to record the video. All right, so this is our model, and it's pretty simple, and it doesn't have much. It has two rooms for the lawyers, so this room and this room. It has a patio which has vegetation in it, and these vegetations are very important because they have a pretty good effect on people who look at them. Like, let's say in the literature of healthcare, they have restorative effects. And we have a waiting area, and we have Peter's desk area. I removed his chair because I can't, my software doesn't account for the chair, moving chair around while the simulation is running. And I'm going to set up the grid. let's say zero point 0.2 is a decent number. And I'm going to remove the grid from the view just to simplify things and then let the visualization run faster. And now I want to create a series of activities. Well, actually, I'm not going to do that, but I'm going to load them from an external file that I've prepared before. We would be talking about creation of activities in much detail later. And then I'm going to create a scenario. Sorry, wrong menu. Create a scenario. So I go to the mandatory scenario and then I load the sequences of activities in here in a similar fashion from an external file. And when we have created the sequences, we can actually visualize them too. So if I want to visualize the sequence that we talked about, lawyer one call, then all we need to do is actually to select it and press this visualize button. So you can see that the sequence starts with this reddish destination. This is activity engagement area, and it goes to this uh, Peter's desk. And then we have another similar activity for lawyer 2, and we have client 1. When the client 1 receives, Peter goes forward and greets them, welcomes them, and then goes back to his desk, enters their information in the in his computer or writes them in a piece of paper. And same is true for client 2. So pretty simple and straightforward. And I want you to draw your attention to something about the scenario itself. Is that let's assume that Peter is done with all of the sequences and currently there is nothing to do. Then Peter will go to the main destination, which main station, which is assigned to him. And so for that we have to have this main station for for Peter also, which happens to be his main desk. But when Peter is at his main desk and there is nothing to do, he would be actually taking care of other things, or he might be checking Facebook, who knows. I mean, I would happily allow him to do that in my virtual environment. And when we are done with that, we get something which looks like this. And these are sequences that are ordered based on their priority. And after one of them is addressed, it will be removed from this queue and it will be reactivated and put back into the queue again. Okay, maybe with the real example, we can actually uh, show that in a better way. So this is our model, and to run the simulation, you go to the mandatory scenario and mandatory navigation control panel. You locate the agent and then you just hit the start simulation button. Okay, sorry, I forgot something that I need to do. I'm going to create a visual event as well. So a visual event is created by selecting cells or areas, and I have a bunch of trees or bunch of visibility targets that are very beautiful, and they have restorative effect on Peter or anyone else who sees them. And well, this is the entire area that is visible from these targets, but it doesn't mean that if you are in any of these points, you have necessarily a view to the target. That depends on the agent's orientation as well. So let's go ahead to the control panel again and locate the agent and start running the simulation. And you can see that Peter has started walking around. And we have a bunch of parameters in here that are noteworthy, and I want to talk about them. So I can here change the velocity of the of agent and make him run faster. I have other parameters in here. I have barrier repulsion setting and I have visual setting. Let's start with visual setting. I want to visualize the destination. So the destination that Peter is headed to is actually highlighted in a stronger color. And we can We can actually activate the safety zone, safety buffer for collision detection. We can check to see if the collision is happening with keep track of the collision, possible edges that the collision may occur, and repulsion forces. And we can actually view what Peter can see. And you can see that we have Peter's view in here, and we can actually capture visibility events. And I don't want you to be so much distracted, but visual events are actually something that are really important, because being in the potential visible area does not guarantee that visibility exists. Check Peter as he's walking through this area. Okay, visibility exists, it doesn't exist. And if you want to know why, because there is a visibility angle, and you can change the visibility cone for Peter by changing these numbers, his cone of vision, and I can make Peter run faster. I'm not sure if this is a very good idea, because you have to fine tune the parameters in a way that they make sense. Later we will see that we can actually fine tune the parameters based on the data that we have captured from a real agent, but for the moment it's just visual. And when you increase the velocity, for instance, then the collision will be expected to occur. And I'm actually going to show the safety buffer, and you can see that the collision may occur. Okay, so this was a description of the whole simulation visually, but the main question is that why, as an architect, I should care about that. This looks interesting probably to some of you, but why is it important is another question that you might be more concerned with. And to answer that, I want to tell you that you don't really need to visualize anything in here. What you can do is actually capture the simulation results, hours of simulation results in a matter of minutes. And if you do that, then you can take a look at the data and then decide if you really like to put this agent in this situation or in this scenario or not. What do I mean by that? Let me stop the simulation, and then uh, don't forget to clear the agent. And then I'm going to directly create the simulation. I'm going to call that sim1, and 17 as a time step is for visualization, which creates the 60 hertz of visual updates per second. 60 hertz is of course per second, but you can actually increase that number if you are not really concerned with that. Let's say 4 hours of simulation, 6 hours of simulation. And when you run this, it will be running on a background thread, so you can still do your own stuff with this OSM environment. But please do not turn off the simulation. Honestly, I don't know how long it takes, but it may take minutes. And then you have to also make sure that you save your BIM model before you start OSM. Okay. Um, Regardless of the size of the building, this is a scalable process. I mean that if you increase the size of the building, this will not affect the simulation time. If you increase the time, it will linearly increase the simulation time. So for instance, in here, we have captured the results. An hour of a simulation had been simulated in 4 seconds only. And when we get the simulation result, there is going to be a new field in a spatial data control panel, which is called SIM. And it's going to look very different from other types of data that we have. We haven't talked about activities yet. Activities have their own engagement time and events that we will be getting later in this tutorial. But okay, so here we have the simulation transcript. The simulation transcript says that the simulation ran for 6 hours with this time step. The percentage of time that Peter was spending walking is actually 56% of the time. He spent activity engagement was 43% of Peter's time. Poor Peter, he didn't get so much time for himself, nearly 0% time in main station doing nothing. A very demanding job. Okay, so let's take a look at the data. The data will be looking very noisy if you look at that in 3D visualization, because there is randomness in agents movement, and that randomness will be will be visually confusing in some scenarios, in some cases. So sim 1, you can see that there is some randomness in here. This is the walking trail of Peter, and uh, in order to make it more visually informative, I'm going to smoothen the data, and I'm going to consider a cell of size 5 for smoothening. And I'm going to put that in here just to make sure that I will never forget that if I just take a look at the results. And when you do that, you can go back to the 3D visualization environment, and in here you can visualize your data now. You can see how it looks like. So this is the data. This is the walking trail that Peter left behind. Okay, I am going to uh, do some stuff in here. Okay, so this is the walking trail that Peter left behind, and it means that uh, how much time Peter spent in which areas of this building. So if you look at this point specifically in here, it means that in this given scenario, Peter doesn't have to spend any time in here. Or in this given scenario, people will be spending some of his time in here, and this cone shape in here shows that okay, he's actually spending a lot of time in here compared to the other empty areas. But more interestingly, Peter is spending most of his time in the station, and we have seen that Peter didn't get so much chance for himself. So how is it Peter is spending so much time in here, but Peter doesn't have any any time for himself, which means that he's actually doing some other thing in here. You can, of course, I mean, I just want to make sure that uh, this is the correct desk. So let's see. Yeah, this looks like Peter's desk, and this looks like the next lawyer's desk, and yeah. So the okay. So here might be the important thing for many of you. Is it possible for me to see how much time Peter is spending specifically doing his own job at this specific activity behind this desk? Or is it possible to see how much or how what percentage of time is actually Peter is capable of looking at these beautiful shrubs or restorative view to the nature? The answer is yes. And if you want to do that, you have to create an event. Okay, I'm going to go to the data control panel, and so these are the activities that we have, right? And then you can see that we have activity engagement apart from the general statistics of the data. And then we have an option which says that consider in capturing event. What an event is, I'm going to talk about that later. But for here, I'm just going to make it very simple. So let's say that how much time we want to create an event for main desk. Okay, I'm going to remove the checkbox from all the other activities that we have in here and only remove it for the main desk. And then I am going to do something else too. I go to the main menu, sorry, mandatory scenario, and then capture events. And I'm going to give this event a name. I would call this main desk event. And I want to store the data as well. So Um, and I want to do the frequency analysis. I want to evaluate. I don't want to include the spatial data, and I don't want to include visibility. I just want to include activity engagement. Time is step 17 and simulation time 6 hours. And then just run the simulation. All right. So I just wanted to, okay, when the simulation is running, I wanted to emphasize that visibility is actually very important and is one of the key concepts behind developing OSM. And being in the potential visible area doesn't guarantee that visibility exists. Okay, with that out of the way, I want to say that when the event is captured, it's going to be another field of data in the spatial data control panel. So we have this main desk event in here, and we have new information. So the transcript is actually very different. We have the simulation type, the duration type, the likelihood of occurrence in here, which is very important. And we have the maximum velocity, which is 5, and then we have the duration, which is 6 hours. And this event has captured activity event, and we have uh, this Fourier series transformation in here, which tells us what is the frequency of this activity happening. So we can see that these are very high frequency and these are low frequency. We probably can filter them and get these data only to represent what is the frequency of activity, how often this event occurs. But this number is actually very informative to us. And we have also a spatial data associated to that we can visualize it. So I can go back in here and then visualize this event, which called was activity event, main desk event. You can see that it was expected, and this is clipping the whole activity with a clip which actually only preserves this activity only, and then the rest of the floor is actually gone. So let's take a look at the other one, which was sim 1. You can see that this is there and the other walking trails are there, but for the main data event, that is not there anymore. Main desk event, that is not there anymore. We have only this guy. And when we have this guy, we have also the statistical likelihood for that to happen. Okay, and let me quickly go and create a new activity, a new event. And this new event, okay, before I do that, I want to show you that when we have captured this event, we have actually the data in in here stored. So this is the data that we stored, we captured. You see that most of that is null for 6 hours, but occasionally we have the location when the event is happening. We have the location, we have the velocity and direction of the agent as well. And you see that because it is in the station, the velocity is 0 and the direction is actually uh, pretty straightforward, and the location is the location, a location inside the inside activity main desk at Peter's desk. Okay, so let's create a new event for visibility only, and it's important to know that we can combine all different types of events with each other. So I'm going to create an event for visibility and include Fourier transformation, evaluation, event setting. We don't have data from a spatial data or activities. We want to include visibility event only, and we want to capture only the cases that visibility exists. We can flip that and capture the cases that visibility does not exist, but we are concerned with when visibility exists in this case because we want to see how much Peter can benefit from the restorative view to this nature. And again, I'm going to make these adjustments, and this is the sampling rate, by the way, and which you can change it for storing the data in a file. We run the simulation and we wait for the results to come. All right, it's quick, and I'm not going to smoothen the data because I want to keep this video as short as possible. All right, done. So now we have this visibility, potential visible area on the background, and we have captured an event which is based on that. But there is a fundamental difference between these two events. First, take a look at the event, and it's called visibility event in here in your data control panel, and it has all the other features. It has captured uh, visibility, sorry, I was clicking, I was showing the wrong data. It has captured visibility, and there is a likelihood for that to happen, which is 30%. So 30% likelihood is actually pretty good. I guess Peter is actually a very lucky person. But who knows? Maybe the view is not as beautiful and as restorative as we thought. And we have this event, and if I visualize this event in 3D, you can see that where this event is happening. Okay, I'm not smoothing the data, but take a look at this. This area of data is gone. This area of data is gone. This area and this area of data is gone. What does that mean? Does it mean that we simply clip the data? No. Because Peter might spend some time still in the potential visible area, but because these visibility targets are not in his cone of vision, then that time and that location will not be accounted for. So this is not simple clipping. This is uh, uh, more sophisticated than that, in a sense that Peter's orientation is also accounted for. Okay, so I want to go back and wrap up this data. I want to go back to the data control panel. And I want to say why this is important to do all of this and draw your attention to that issue specifically. So we have a simulation which reports how much Peter is walking, how much Peter is actually engaged with activities. And we have a simulation which says that what is the likelihood of having a good view and what is the likelihood of getting engaged with that specific activity. If you are a designer, an architect, urban designer, and you are concerned with a specific case in your scenario not to happen, and you are concerned with a specific case that you want to happen, then you want to change your design, your building layout in a sense that these likelihood be increased or decreased. So for instance, we want to increase the number, the chances of having visibility for everyone. So for instance, in healthcare, which is a subject that we would be moving later in later tutorials, then this is critically important that we have a nurse has a view to the patients. And if this is an area that you don't want to be, this is a number that you want to decrease it, this will give you insight in order to make the right changes in your building. What are the right changes? I don't know. But what is the likelihood for that change to be improved or be uh, be worsened? I can tell you that with this evaluation, and this simulation provides you the insight by evaluating your design. We have seen visualization and evaluation in this scenario. In the rest of these tutorials, in this series, I am going to discuss all of these topics in much greater length. I hope you have found this video educational and hopefully entertaining so far. And I will hope to see you in the later tutorials. Have a good time.